Hello, this video is to show how to do mole particle conversions. The sample question that we have is how many copper atoms are there in 2.4 moles of copper? Now, first of all, we have to, as always, write down our starting point and end point. The starting point is the number, unit, and identity given to you in the problem. So 2.4 moles of copper. And the question is, how many atoms, which is a type of particle, of copper are there? Now, next we have to write out our equalities. Now, in order to figure out the equalities, we utilize our chemical conversion map. And since our starting point is in moles, our end point is a type of particle, and we're going from mole island to particle island, the bridge that we use is Avogadro's constant, which reads 1 mole of a substance is equal to 6.022 times 10 to the 23rd particles. Now we have to specialize and specify for this particular problem. So we say that 1 mole of copper is equal to 6.022 times 10 to the 23rd, and instead of particles, we utilize atoms of copper. Now, since this gets us to our starting point and only one bridge is needed, we only therefore need one equality. We set up our grid. We have 2.4 moles of copper in the top left-hand cell. Moles of copper are here, so therefore we need moles of copper down there. Therefore we put 1 mole of copper on the bottom and 6.022 times 10 to the 23rd atoms of copper goes on top. Moles of copper cancel out. We're left with just atoms of copper, which is exactly where we want to end up. Now we use our handy dandy calculator, and we go, since it's on top, we simply go 2.4 times 6.022 EE23 equals. And rounding it off to the correct number significant figures, which in this case is 2, since there are 2 significant figures in the starting point, our answer is 1.4 times 10 to the 24th atoms of copper. Now, let's say we want to go the other way, and we have a question like, how many moles of iron are there in 4.8 times 10 to the 27th atoms of iron? So in this case, our starting point is 4.8 times 10 to the 27th atoms of iron. And the question is, how many moles of iron are there? Again, we utilize our chemical conversion map. This time we're starting off on particle island and going to moles. But again, we use the same bridge, which is Avogadro's constant. But we have to specify for this particular problem. So instead of 1 mole of copper, I say 1 mole of iron is equal to 6.022 times 10 to the 23rd atoms of iron. Notice how it's exactly the same number. Only thing that's changed is the identity of these substance. So I set up our grid again, since we only had one bridge. I have 4.8 times 10 to the 27th atoms of iron in the top left-hand cell. This time, since we have atoms of iron on top, we want to have atoms of iron on the bottom. So we use this right here. We put Avogadro's number of atoms of iron on the bottom and 1 mole of iron on top. When we use our calculator, well, first of all, cancel out atoms of iron, leaves us with moles of iron, which is exactly where we want to end up. This time, when we use our calculator, instead of multiplying, since it's on the bottom, we're going to divide. And we have 4.8 EE27 divided by 6.022 EE23 equals. And I get 7,970. Again, we only want two significant figures. That 7 changes the 9 into a 10, which changes the 7 into an 8. So my answer is 8.0 times 10 to the third. All right, because the exponent's greater than 2, it has to be in scientific notation. Times 10 to the third moles of iron. And there's my answer. I hope you found this helpful. Thank you.